Hey, Algebra 2. We're going to work on a second step on inverting functions. So whenever we work on algebra, it is always great to check our answers. Very often, that involves plugging our answer into the equation, seeing if it works. Or it involves checking with a friend. What did you get? Or it involves looking at solutions or whatever. Um, there is a method for checking to make sure that two functions are inverses of each other that doesn't involve any of those things that you can do on your own. The first thing that I am going to do whenever I take these steps, and you'll see this in my posters and solutions and all of it, is I will write out the original and inverse functions, put them side by side. The process we're about to do looks pretty complicated, but if you can keep it organized, it's pretty simple. It will kind of work itself out. So the original function that I had was y equals 3x plus 7. I'm actually going to switch to function notation for this. This will help me out. And then I'm going to use lots of colors, surprise. So this is from the previous video. We were given the equation y equals 3x plus 7, and then we inverted it. And so that was the original one. The inverse turned out to be y equals x minus 7 over 3. Okay, and notice I am not putting y. I used function notation, f negative 1 of x instead of y, or f of x. Okay, the way that we prove that that two functions are inverses, I think this is really cool. We take one function and put it inside the other. We substitute it inside the other function. So in this case, what I'll do is I'll take my original function and I will replace x with the inverse. So I'm going to use colors here to show what I'm talking about. Okay, my x's I'm putting in red. This will be a little bit of a weird notation thing. The main focus is just that this inverse function is going to go in there for x. So where it used to say x, it will now say x minus 7 over 3. I am replacing x with the inverse. I'm substituting the inverse in for x. And if I've done this right, since I inverted all of my operations, they should all cancel each other out. I have all the opposite steps in the opposite order, the inverse steps in the opposite order. Okay, this is what I want you to be able to see. I'm taking the original function, I'm taking x out, and sticking the inverse in. Okay, the left side is going to look confusing. If you use colors, I think it will help a lot. And it's just a matter of record keeping, of notation. This is me showing, says f of f inverse of x. It's saying I am plugging f inverse of x into the function. Okay, pay attention to the way I write that. Don't obsess about it. You'll be fine. After you've done this, after you have substituted one function into the other, the steps should follow really naturally. Oops, an alarm. So what should happen is things will cancel out. In this case, we'll have 2 rounds of things canceling out. Right now I have x minus 7 divided by 3 times 3. Those will cancel. And I am now left with f of f inverse of x equals, the 3's are gone. I have x minus 7 plus 7. Shocker, the plus 7 and minus 7 are going to cancel. We knew that was going to happen because we made an inverse function. We made a function that's made up of inverse operations. And we're left with just x. That's how it should work. If the two functions are inverses of each other, then your final answer should just be x. Everything else should cancel out. Technically, to really prove it, you need to do it both directions. So I also need to plug the original function into the inverse. So I'm writing out my original function, but I'm going to write the x's in blue. That is my way of telling myself, ooh, this is going to be fun, that I am plugging the original function in for x. And so the way this will be noted is I'll say f of x. I screwed that up already. It should be f. Wow, this is really hideous. Let's try that again. This should be f inverse of f of x. When I look at this, I can see the original function plugged into the inverse function. And then over here, I'll leave some space. I am plugging 3x plus 7 in for x. I'll use parentheses there. You don't have to, but it kind of looks nice. I replaced x with the original function. Okay. And then we'll have cancellations. The positive 7 and the minus 7, those cancel out. I have f inverse of f of x, the original plugged into the inverse, equals, well, the 7s are gone. I still have a fraction, but I just have a 3x on top, a 3 on bottom. The 3's cancel, and I am left with f inverse, ooh, I don't know what that symbol was, f inverse of f of x equals just x, like it's supposed to. And I don't know, I can write some note that says, like, yes, they're definitely inverses. Ooh, I am struggling with writing right now. Look at that, worst handwriting ever. Beautiful. Okay, I think time-wise, I know you've seen a lot of video and heard a lot of me talk about math. So let me show you the first half of the second problem we did. I want to show you that though it might look more complicated, it's really not. Time-wise, I'm not going to do the second half. It's on a poster and it's on notes on Canvas, and you can slowly work through solutions. I've already started this one out. This was the second problem I did in the previous video. This is the original function. This is the inverse. Okay, I will plug the inverse into the original. I should also be plugging the original into the inverse, but again, just time and exhaustion wise, let's just be done with it. I'll just do one of them. You can kind of see that example, and then I want you to try and practice on your own. And so what I'm doing right now is I'm writing the function around the x. In place of x, I'm going to put f inverse of x, and that means I'm plugging in square root of x plus 5 minus 2. Ooh, square root of x plus 5 minus 2. Whew. All right, that's pretty squishy. Okay, there's going to be 3 steps of elimination. Minus 2 and plus 2 cancel. Again, if you just look, the x becomes the inverse function. X becomes square root of x plus 5 minus 2. 2's cancel. I have f of f inverse of x equals, now I just have square root of x plus 5 squared plus 5. Oops, do you see what I screwed up already? That's minus 5, and I changed it to a plus 5. Oopsie. So let's fix that. I noticed looking ahead that things weren't going to cancel like they were supposed to because I messed up. So the square root and squared, those are inverse operations. They cancel. I have f of f inverse of x equals no square root anymore. It's just x plus 5 minus 5. Lo and behold, the 5's cancel, and I'm left with f inverse of f of x, f of f inverse of x equals x, which is exactly what's supposed to happen. Everything's supposed to cancel. I'm going to stop there. You've seen enough of me. This one is similar steps. In fact, I'll just show you the steps all the way done without talking through the whole thing. Okay, so I just went through and completed that one on the right. I'm not going to go into details in it, but you can see, hey, look, everything canceled out. I inserted the original function into the inverse, and I'm left with f inverse of f of x equals x. As long as both of those turn out to be x, as long as both things had everything canceled, you're good. Okay, good luck, guys. Again, reminder on the worksheet, skip those first 2 pages. You could start on them. I'd rather you not. I'd rather we save those for Thursday, for tomorrow. Skip to problem number 5, 5, 6, 7, 8. Do those instead. All right. Thanks, guys.